So good afternoon. Today we are going to study about this example of the cylindrical coordinate system as the last example, and then we will go to the spherical coordinate system, and also we'll study the derivative differentiation of the vector functions. So here is an example to study the cylindrical coordinate system. So there is two vectors are given. A vector is given in this way. So A rho, A phi, and A g. So from this unit vector, you can understand this vector is given in the cylindrical coordinate, and the B vector is also given as a basis of the A rho, A phi, and A g. So B vector is also given in cylindrical coordinates. So in this case, given at the point P, I think I'm sorry. I think we already studied this example last time. So we already have done. So as I mentioned, these two vectors are not in the same phi. So that's why this A rho and this A rho are different. It's not the same. And this phi and this phi in the different orientation. So that's why you cannot add this number directly. It should be transformed into the XYZ coordinate or the rectangular coordinate system. So, okay, we already have studied. Okay, let's go to the next example. Why is it not going? Okay, we already have done. Okay, so then I think we can go to the spherical coordinate system. Okay, so the spherical coordinate, I also okay, last time we also studied a little bit on this system. So in order to indicate the location of any arbitrary point in the three-dimensional space, we also can use the spherical coordinate system. So we already studied it can be written by the radius and inclination angle and the azimuthal angles. And these numbers r, theta, phi can be transformed into x, y, g using this relation. So this relation can be written in the matrix form, as we already studied. So the matrix, where is the matrix? Okay, the matrix come in the later. So how can I use it? Okay, I explained this slide, and let's go to why is it not going? Okay, not this, not this. How to use it? Okay, I mentioned the each direction vector or unit vector AR, A theta, A phi, and they are orthogonal each other. 서로 수직이고요. And they have these relations. These relations. So they have the special relation with the angle rotation. So AR cross A theta equal to A phi, and then the order should be rotated, and then the same relation you can obtain. If you change the order, then it should have the minus sign. Okay. Okay, so on this example, so two vector, A vector and B vector are given at a point P. So the point P is given by this R theta phi. So it means A vector and B vector is located at the same position. For example, in the x, y, g coordinate, P vector is given at this point, and the vector A is given at this point. So, for example, A vector is locating, A vector is like this, and B vector is like this. So, it means A vector and B vector have the different magnitude and different direction, but both of them are located at the same point. Okay, that is the key. So that means the AR, A theta is A phi, and this AR, this A theta, this A phi, are the same, because these vectors are related with purely depend on the location of the point. So as they have the same point, these vectors are also the same. Okay, and then we can do the calculation directly, like rectangular coordinate. Okay, so for example, A vector plus B vector directly can be added. 10 minus 3, so 7 AR. In this way, we can do it. So in this case, the AR, A theta, A phi doesn't need to be changed into the X, Y, G. Okay. Last time, few students asked me some questions, and they may have some confusion on the position vector and the general vector. The general vector is not the position vector. Position vector is always like this. So the position vector starts from the origin point, and the end point is the coordination. That is called the position vector. But it is some special case of the vector. Generally, the vector doesn't need to be always in the original point. So the original, the general vector is nothing to do with the position vector. Okay, so in this case, 2a minus 5b. In this case, you can directly multiply 2 and 10, so it will make 20, and the minus 5 multiplied by minus 3, so plus 15. So then you can do this sum. Then you can get the AR vector coordinate. So in this way, the R component, theta component, and phi component can be done directly, and also the dot product also can be done the same as you already done in x, y, g coordinates. So in case of the x, y, g coordinates, x dot b dot was given by this way: ax bx plus ay by plus ag bg. So the same way you have done in the x, y, g coordinate, also it can be done ar br plus a theta b theta plus a phi b phi. The same way you can do. Why? The x this ar is the same vector, and this theta, this vector, the same, and they are orthogonal each other. So that's why you can do it in this way. Similarly, the cross product A cross B also you can use the same equation as you have done in x, y, g coordinates. So directly you can get the result. And I think the other examples also can be done by yourself. So I think I can pass this example. You can do it by yourself. So you already studied in the engineering mathematics. Okay, so now we are going to study the transformation matrix. So you can get these terms from by considering the rotation of the AR vector, AR theta phi, and the relation with the XYG. You can obtain this kind of the relation. So from this from this diagram, you can get some get some hint from this diagram. The relation between the AR, A phi, A theta, and the AX, AY, AG. So, for example, let's think about the AR vector. Yeah, so AR vector is pointing the outward direction from the origin point. So it is the AR vector. So if this AR vector, the point is on the x-axis, then the AR vector should be the same as the AX in case of this point. In case of this point, if the position is located on this point, then the AR vector is the same as the AR vector, the same as the AY vector. Yeah. So depending on the position, the AR vector is changed. So simply, you can understand in case of the theta equals 0, AR vector is located on this point like this. AR is the same as AG. Okay. So then I can say the AR vector is related with the AG vector, like this. When it has the 0 theta, then AG is equal to AR. And if the theta is increased, so for example, if it is rotated onto the equator, 적도 근처에 오면, then the AR component do not have the AG component. And if it is located on the north pole, 북극점에 있을 때는, 지구상에서 북극점에 있을 때는 AR 벡터가 AG 벡터와 똑같죠. So then I can write in this way: cosine theta. If I write this factor, cosine theta, then when it is located on the north pole, 북극점에 있으면 theta가 0, theta equals 0, and then cosine theta equals 1. So then AR is the same as AG. But if it is in the equator, 적도 근처에 오면 theta가 90도, cosine theta는 0이 되니까 AR component do not have the AG component. In that case, the AR is composed of the AX and AY because it is on the XY plane. And if we go to the south pole, then south pole theta equals 180, then cosine 180 is minus 1. So the AG is equal to AR, minus AR. Okay? So because the AR is pointing down and the AG is pointing up, so it is in an opposite position. So with this component, you can got we can make the relation between the AR and AG. And also, you can, there must be another factor which is related with sorry. Okay. For this, you don't need to put any factor because the G component purely related with the theta. But in case of the AX, okay, we know from the cylindrical coordinate system, for example, now let's think about this XY plane. In XY plane, the AR component so generally, if the R point is located on this, then it should be decomposed with these two vectors. Okay, this vector and this vector, making the parallel square. So this line okay, so it is the AR vector, and from the AR vector, AX component is given by this way. AX component. So this length is cosine phi. Okay. Cosine phi. And it has the AX component, AX direction. The AX direction is have the one unit magnitude. 크기가 1이니까 방향만 가지고 있고요. 크기가 1이고 여기서 여기까지의 길이도 1. The magnitude is 1, and it is decomposed onto the x axis. And also this line is the length is sine phi, and the direction is y direction. So if it is located on the xy plane, 적도면에 있을 때는 이렇게 쓸 수가 있죠. 적도면에 있을 때. 그럼 이제 적도가 아니고 북극도 아니고 그 중간쯤에 있을 때는 어떻게 되겠어요? 그 중간쯤에 있을 때는 여기다가 요 팩터만큼을 곱해 주면 되겠죠. 이거는 이제 G 방향, x-axis component. So the xy plane component must be the sine theta instead of the cosine theta. So in generally, in this case, the x component and the y component and the g component can be written by this way. So g component must be cosine theta, and the direction is AG direction because it is parallel to the g-axis. On this case, instead of the cosine, it must be changed by the sine theta. And also the xy component also decomposed into these two factors. So sine theta and sine phi, and they have the AY. Okay, it's not working. AY direction, and in this case, sine theta, cosine phi, and a x direction. So in this way, we can decompose the AR vector into the x, y, g. Okay. So then I think you got the point. So all of them can be summarized with these relations. So from the AR vector, a x component is given in this way. So it is a projection, AR vector projection onto the x plane, x direction is a cosine theta, sine phi. And AR vector projection onto the AY direction is a sine theta, sine phi. So in this way, the other direction also can be done. So it's some tedious process to get all the relation. So it is the purely mathematical mathematical thing. It's nothing to do with the electromagnetics. So I don't want to explain all of it, the details, but I just give you the idea of how they are related with each other. So we can obtain the 9 component, the relation, angle relation between the r theta phi and xyg. Okay, so these relations can be written in this the matrix equation. So from this matrix, you can obtain the relation. You can write down the relation in one equation. Okay, so AR, A theta, A phi, and AX, Y, G. So X, Y, G component can be transformed into the R theta phi. And this matrix, you can get the inverse matrix. 역행렬을 계산할 수 있죠. 역행렬을 계산하면 그러면 거꾸로. So R theta phi can be transformed into the XYG. So similarly, this relation is about the direction vector relation, but the same relation also can be obtained for the each component. So in the next slide. So each component, each coordinate component also can be written with the same matrix. So this matrix is the same as the matrix on the previous slide. And about this relation, so from R theta phi into XYG instead of the XYG into the R theta phi. So then this matrix, you can get inverse matrix. 역행렬을 구하면 the inverse matrix is the same as this matrix. Okay. So most of them are similar, but have the different sign, and some part cosine is changed by the sign, and but the forms are very similar. So the important thing is, do you need to remember this matrix? Do you think you need to remember this matrix? The answer is no. You don't need to remember it. Okay? So some students who don't get a good grade may try to memorize all the matrix, but the physics is nothing to do with the memory ability. You don't need to remember it, but you need to know why, how it was derived. That is the important point. Okay, so by using these matrices, so this matrix is called the transformation matrix. So using this transformation matrix, you can transform the coordinate system. Okay, so here is an example. The vector f is given at the point P, 3, 4, 12 in rectangular coordinates, and express this vector in the spherical coordinate system. It is a relatively easy example. So the point is given in this way, and then if you want to change the coordinate system into the spherical coordinates, then absolutely you first know what is the R theta phi. The point P should be expressed into the R theta phi. Okay, so what is the R? R? What is R? There is no R. So R, yeah. From the Pythagoras theory, you know the R is given by this way: square root R square plus x square plus y square plus g square. It is the R. You know. Yeah. And also the theta phi, theta is the cosine R g over R. We already studied at the first slide on the spherical coordinate system, and similarly the phi is the tangent. Am I right? Yeah, tangent y over x or x over y. Tangent. So tangent. Okay, x over y. Okay. So then inversely you can obtain the. Oh, sorry. It should have the arc. Yeah. So cosine theta equal r over g over r. So the theta equal arc cosine g over r. Yeah. So from these three relations, you can obtain the r theta phi. So this number is r. So you need to know the R at first. So R can be obtained by Pythagoras theorem. And also, you can put these numbers, x equals 3. So the x equals 3, the y equals 4. So x equals 3, yeah, and the y equals 4. Then you can calculate f. It is the same as this, x, y, g, in x, y, g coordinates. And then now you know this line is fx, fy is 8, and fg is 36. And then using this matrix, you put the 9, 8, 36, and then you can get the fr, f theta, phi. In this case, you need to use the calculator. So using your calculator, you can obtain this result. Okay, and then directly you can write the vector f can be represented by the r theta phi spherical coordinate system. Okay. And also, when you represent the point P also need to be represented in the r theta phi coordinate instead of the x, y, g. Okay. Okay. Now, the scalar and vectors. So you are already familiar with the vector, and you know the difference of the scalar and vector. So generally, in order to represent some physical property, you can use the scalar or vector, depending on the physical quantity have the information of the direction or not. For example, the voltage. When you say the voltage, 전위, 전압, volt, 100V, 220V. So when we call the volt, we only mean the magnitude. 크기만 얘기하지 방향은 없죠. 전위를 얘기할 때 1.5V 건전지 1.5V. We don't need to you don't need to mention about the direction. In that case, you can use the scalar. So that is the scalar. But some physical property have the information of the direction. For example, if we express the field, electric field or the magnetic field, then the field not only have the magnitude, but also it has the direction. So the direction also should be represented. So the electric field have the magnitude of the 100 volt per meter into the direction of the minus y direction or xy plane direction. So then this physical quantity should be represented by the vector. So you already know. Yeah. And it's not important. Let me skip it. Okay, then now let's consider about the vector calculus. So this calculus, vector 계산, mainly we are focused on the differentiation. 미분, vector의 미분. We're going to study about the vector calculus. So it is the definition of the differentiation. 미분의 정의죠. 스칼라 함수에 대한 미분의 정의는 이렇게 주어집니다. It is you are already familiar with this definition. d phi ds is given by this way. So the quantity, the small change as you are changing the variables, that change should be divided by the difference of the variable, and you can take the limit of the infinitesimally small number of the change. Then you can get the differentiation. Every student knows this. And also, I think some of the students already studied the partial differential, 편미분, partial differentiation. So, okay, it is the partial differentiation. It is the total derivatives. 전미분을 할 때는 편미분, 각각의 컴포넌트에 대해서 편미분을 해서 전미분을 하죠. It is about the scalar function, but now the new one is the vector differentiation. The vector function function f is given by the vector, as it has the arrow symbol. So it means this function f is the vector function, not the scalar function. Then, for the vector calculus, what is the difference? There is no difference. The same. Originally, we have this definition, and for the vector, the same definition. Okay, see, this equation and this equation, nothing different. Only the difference is the arrow, this arrow. Yeah, originally this vector was the scalar. They don't need to write the arrow on top. But in this case, originally f function was the vector, so that's why this function and this function should have the arrow symbol, meaning this quantity and this quantity is the vector quantity, not the scalar quantity. So the vector quantity, so this vector and this vector may have the little change of the orientation. 방향이 조금 다를 수가 있죠. 이 벡터와 이 벡터가 가리키는 방향이. 그 방향까지 고려해서 요 빼기를 해야 된다 이 말이에요. That is the only difference of between the vector differentiation and the scalar differentiation. And also the partial differentiation, 편미분할 때도 똑같아요. 이 공식이나 이 공식이나 똑같고, 단지 다른 거는 요거를 벡터로 간주해야 된다. 요것도 벡터로 간주해야 된다. 벡터기 때문에 얘가 가리키는 방향과 얘가 가리키는 방향이 다를 수가 있죠. 같을 수도 있고 다를 수도 있어요. 그럼 만약에 다르다면 그 방향이 다르다는 걸 고려해서 계산해라 이 말이죠. 그것만 다른 거지 다른 건 다 똑같아요. Okay. So if you study the 공업수학 engineering math, you already studied. Okay, and then the volume element and the length element and the area element. You studied these length element in your high school math, but now we are talking about the three-dimensional space. In three-dimensional space, if you want to do the integration, 적분을 하려면은 최적에 대한 적분, 면적에 대한 적분, 그리고 길이에 대한 적분, 이렇게 달라진다. So, in case of the volume integration, for the volume, it does not have the information of the direction. So, the volume integration can be done with the dV. So the V is the volume and the dV means the small change of the volume. So the small, infinitesimally small volume is represented by the dV. So dV, if it is the x, y, g coordinate, it could have the x component, y component, and g component. And as you multiply each directional component, then you can get the volume. So the x 성분, y 성분, z 성분 곱하면 차적이 되는 거니까. So the volume dV can be written by the dx, dy, dz. Okay. And now let's think about the area. So when you do the surface integration, in case of the x, y, g coordinate, we can think about the three independently different direction. So, for example, this surface is normal to the x direction. So then this element have the scale of the dy and dg. So as you multiply the dy dg, then you can get the area of this surface. So and this surface is designated by the sx. So s means the surface, and the x means this surface is normal to the x direction. So the sx is dy dg, and the direction is x ax. So generally, when we define the direction of the surface, the direction is defined as the normal vector direction of the surface. So in this case, ay direction, there is one more surface. So this surface have the x component and y component. So the surface is dx dg, and the orientation is on the y direction. Similarly, ag direction, it have the x component and y component, and the orientation is defined as the normal direction. So ag, that is a more general way to represent the direction of the surface. If you want to take the direction of the parallel to the plane, then there are two independent planes. So that's not a good way to define the surface, the orientation of the surface. Instead of that, the normal component is the more easy to represent the direction of the surface. Okay. And in case of the length component, the length also may have the three different lengths. So the x direction, y direction, and g direction, or more generally, they could be combined partially. So the x component is represented by the dx, y component dy, g component dg, and each component have the direction. So the x component have the ax direction, y component also have the y direction, and g component also have the g direction. So you can combine the x, y, g. You can get the general length component, change of the length. So the length and the surface have the direction. So it is a vector. So ds, these are vectors, and the length is also have the direction, as it has the x component, x, y, g. So generally it has the length. So the length element and the surface element is vector. But in case of the volume does not have the special direction. So the volume is a scalar. Volume is scalar, but the surface and length is the vector. Okay, so in case of the x, y, g coordinate system, it was easy. It was easy and very conceptual. By intuition, you can understand it. But in case of the cylindrical coordinate, it is a little bit complicated. So in case of the cylindrical coordinate, let's consider the small part of the small element of the volume in the cylindrical coordinates. So it is a good example. Here is a pineapple. So the pineapple have the cylindrical shape. And if you cut the pineapple, then you may have this shape, this form. Okay? One piece of this pineapple may got this form. So in this case, what is the volume of this this piece? You may be a little bit confused. It's not easy. So conceptually, it's not easy. The thickness is easy. The thickness, if you cut the pineapple into the XY plane and another slice, then the thickness is the same as the G. But the length from here to here, it's an arc. It's not straight line. 이게 직선이 아니고 호예요, 호. 직선이 아니죠. 호죠, 호. So the arc have the angle and radius. 호의 길이를 우리가 얘기할 때는 반지름 곱하기 라디안 각도. So the radius is rho. And the angle component is d phi. Okay, so this length is rho d phi. And how about this? This radius. So if you cut the pineapple with this direction, and the more inside have the different radius. So as you are taking the different radius, you may get the different width of this side. So it can be written by d rho, the difference of the radius. Okay, then if you multiply this part, and this part, then you got the volume, dV. Okay. Then maybe some student may ask, this length, this arc length, and this arc length is different. No? 여기 호의 길이와 이 호의 길이가 다르죠? 이게 당연히 더 길잖아, 그죠? 그럼 이렇게 하면 안 되죠? 어? 이렇게 하면 안 되지? 어떻게 생각해? 이게 정육면체가 직육면체가 아니잖아요. 직육면체라면 이렇게 쓸 수 있는데 이게 직육면체가 아니니까 이렇게 쓰면 안 되겠죠? 안 돼. 이렇게 해도 돼요. 왜 되냐면 이게 무한히 작은 각이기 때문에 이렇게 해도 되는 거예요. 이게 큰 각도라면은 이렇게 쓰면 틀린 거죠. 이건 잘못된 거죠. 이건 틀린 건데 지금 이게 무한히 작다. Infinitesimally small angle, you can get the same. So the length difference from here to here and here to here is ignorably small if the d phi is the infinitesimally small. So we are taking the limit of the d phi go to 0. 극한에서 d phi가 0으로 갈 때는 이 길이와 이 길이가 똑같아요. 그러니까 이거를 마치 직육면체라고 생각하고 그냥 곱해도 된다. Okay? So the volume is given by this way. Rho d rho d phi dg. So you can get this result. 수학의 극한 개념을 공부를 한 사람은 이해가 될 거고요. 예, 극한을 모르면은 지금 이게 잘 이해가 안 돼요. 즉 d phi가 무한히 작아질 때는 이게 직육면체랑 똑같아지실 거예요. 오케이? 그래서 직육면체로 간주한다. Similarly, the surface element. So in case of the ds rho representing this surface. So this surface is normal to the a rho direction. So this ds rho represent this surface. So what is the surface area of this element? From here to here is 2dg. So I'm talking about this surface. So dg, and the arc length is rho d phi. So as you are multiplying these two number, you can get the area. So ds rho is equal to rho d phi dg, and the direction is the normal to the a rho direction. And similarly, so in case of the ds phi is this surface. So this surface, but the direction is on this direction, not this direction, this direction. And the height is dg, and the length is d rho. So d rho dg, and the direction is a phi. And above this, dsg representing this surface. So similarly, this surface, as I mentioned in this case, this surface, even though it looks some curved form, but you can consider it as a rectangular. Then it is the length and width or height. Then d rho and rho d phi, you can get the area, and the direction is normal direction of this surface. So it is pointing the AG direction. And the length scale also can be written by the A rho direction, D rho, and AG direction, G direction, DG. But in case of the phi direction, as you are indicating the a phi direction, it is a rotating direction, and the d phi is only the angle. It's not the length. 이건 각도지 길이가 아니란 말이에요. 호의 길이를 계산할 때는 반지름 곱하기 각도가 호의 길이가 되기 때문에 rho d phi, not d phi. Instead of the phi, the radius rho should be multiplied. So it was the cylindrical coordinate system, the infinitesimal element. And let's go to the next spherical coordinate system. So the spherical coordinate system, single piece of this piece, you can imagine the watermelon piece. If you cut the watermelon, and that piece may look like this. So it could have the radial direction, and also this angle is the phi direction. So phi direction also have the arc. The length is considered as the arc, 호의 길이. So it should be multiplied by the radius. 반지름으로 곱해야 되죠. 각도와 반지름. Similarly, this length is also should be multiplied with the length, the angle difference, and the radius difference. So all this theta, and this length, the arc length is all r d phi and sine theta also should be multiplied. Why? In case of the north or south, the length is much shorter, and it is on the equator. It has the full length of the radius. 그죠? 지구 여러분들 비행기 타고 여행할 때 우리가 비행기가 북극 쪽으로 가죠. 여기 한국에서 미국까지 갈 때 태평양을 건너서 안 가고 북극 쪽으로 넘어간다. 왜 그렇죠? 북극 쪽이 짧아지는 길이가. That component is the sine theta. So in case of the north, this component becomes 0. So the length scale is become reduced. And in case of the equator, 적도 근처에서는 it have the factor of 1, and also the south pole again is reduced. That's why the sine theta should be multiplied on this length scale. Okay, so then each surface element also you can understand with this diagram. This part is separated. So it is normal to the radial direction, 지름 방향, 반지름 방향으로 위치하고 있는 이것이 DSR, and the surface is given by this way. And the theta direction is, what is the theta? Okay, yeah, this one, this one. This surface or this surface. So it is indicated here. So the length. So similarly, you can consider it is a rectangular, not a curved surface. Then easily you can understand the aerial component. And also the length scale, the radial length and the azimuthal angle and the longitudinal length, each length can be decomposed this way. So length scale dr. In case of the d theta, the d theta should be multiplied by the r, because it is the length of the arc, and it is also the azimuthal angle r d phi, and again sine theta should be multiplied. As I explained, if it is on the north or south, the length is reduced, so that factor should be multiplied. So only in the equator surface, it has you can ignore that factor. Okay, so on this table, all of them is summarized. All of them is summarized. So for the rectangular coordinate, it's a very conceptually understand, intuitive. It's easy. But in case of the cylindrical coordinate, you need to think about the length of the arc. So not just multiplying the angle, the radius should be multiplied together, and also spherical coordinates. It is more complicated. So the radius and the angle, and also the sine theta should be multiplied. So you should remember this factor, and also you need to remember this part. You don't need to remember this. It's very easy. But in case of the cylindrical coordinates, d rho, d theta, tg, and the radius should be multiplied. In case of the spherical coordinates, r square sine theta d theta d phi. This component is called the solid angle. So you need to remember this one. But if you understand the geometrically the spherical coordinate system, even without memorizing these factors, but you can derive this relation directly. So r square, because it is the volume element, the r square and the dr, so we'll make the three-dimensional volume, and the other component is only the angle, and the sine theta must be multiplied, considering the north and south reduced length scale. The sine theta should be multiplied. So maybe you need to remember these numbers and these numbers and these. Then it's gonna be enough for you to study the other part of the electromagnetics. And then now, if you understand the infinitesimal elements, then now you can do the integration. 자, 적분입니다. 이거는 적분. So it is the form you are familiar in the high school math you studied. The integration on the scalar function is defined. It was defined in this way. So in this case, the length in case of the one dimension, 1차원 경우에는 you don't need to represent the direction. But now if you are doing some integration in three dimensions, the length scale dl should be the vector. So the f is the scalar function, and the dl is the vector. So scalar and vector multiplication will make another vector, and the basic definition is the same. Only you need to consider this L is the vector, also the vector. So as you do the summation of the vector, you need to consider the direction. And also you can consider these types of the calculation. Vector function and the vector element. So it is vector and also vector. Both of them are vector. So in that case, there are two choices: dot product or cross product. There are two choices. So in case of the dot product, the same definition was the same. Only you need to consider the difference. Consider this vector calculus. It should be multiplied with the inner product definition, and also the vector function and the length element. In this integration, it has the cross product. So cross product, the same. The definition is the same. Only the difference is need to consider the cross product. And one more thing you need to remember is the integration. When you define the integration range, for example, in this case, from A to B, or there is one more choice, from B to A. Both of them is possible, but in the physics, in the viewpoint of physics, this integration should be done to add the values, to add. So by adding the values, it doesn't need to have the negative sign. So if you take the from A to B instead of B to A, then this order is the same order of the direction vector. Then you will have the positive result. If you change the B, A and B order, so from B to A, then you may have the negative result. So considering the original meaning, the adding the value. So from small number to large number, or the initial position to the pointing orientational direction. So this order should be chosen in that way. Okay, it's hard. Okay, so here is the example. So it is a good example how much you understand the integration of the vectors. So here is the vector function A is given in this way. Okay, A vector is given in this way in x, y, z coordinates, and this calculation should be done from point P to Q. So on this coordinate, P is 0, 0, 0. So P point is the origin point. 원점이고 P점 원점이고. Q point is 1, 1, 1. So Q point is here. It is the destination point. So starting point and destination point. And you do this line integration with the dot product. So from P to Q, but it is a vector calculus. So the path there is the arbitrary choice of the path from P to Q. So from P to Q, you can go directly with a straight line, or you can rotate some surface and you can go to the Q. This path or any other path, there are infinitely many choices. So on this example, the first choice is x equal to t, y equal t square, and g equal t cube. So just changing the t values from 0 to 1, you can get some special path. That path is gonna be something like some curved line, like this, or yeah, probably like this, this way, or the straight line from P to from 0, 0, 0 to 1, 0, 0. So from here and to here, and then go to 1, 1, 0. 1, 1, 0 point is here. So from here to here you go, and from this 1, 1, 0 to 1, 1, 1. So this line and this line and this line. So finally you can get the destination. So from P to Q, follow this path. And another path is a straight line. So from P to Q, the shortest line is this way. Okay? So using the different paths, you can do the integration, line integration. Okay? So I think I don't need to explain everything, but I will just only explain the case C. Okay, but you need to know all the cases. It's not difficult. So let's do this case C, straight line from P to Q. So this path, on this path, this point is 0, 0, 0, and this point half, half, half. On this point, 3/4, 3/4, 3/4, and 1, 1, 1. That means x, y, g must be the same. So this line means x equal y equal g. Okay? If you give this constraint, then all the point must be on this line. You know, in case of the x equal y equal g, then it should have this straight line. So then you can consider this constraint. So this vector A can be changed by 4x plus 9 y equal x. So y equal x. yg is equal to x, so it can be written by x squared and x cubed. Okay, so then the A vector is the same as 13x NaX minus 14x squared AY plus 8x cubed AG. Yeah. Why? Because y equal x, g equal x. Okay? Then you can do this calculate. Oh, you don't know what is the DL vector. DL vector is the vector pointing this direction. Yeah, DL vector is pointing this direction. So this direction is not the x direction, not the y direction, not the g direction. The x component, all of them are equally combined. So then you can write DL vector is the same as A dx AX vector plus dy AY vector plus dg AG. Okay, then you can have the DL. Why? This vector, you can decompose this vector into the x component, y component, and g component. All of them are equally contributed. So x vector, y vector, g vector. So x, y, g sum. Then you can have this angle, the 45 tilted angle. Okay. So instead of DL, you can use this form, and the A vector. Now, originally it was you have the 3 independent variable x, y, g, but x, y, g is merged into x. So you only have one variable. 변수가 하나만 남았어요. x에 대한 변수 하나만 남았기 때문에. Then now you can do. So maybe in the next slide there must be okay. So in case of G and the range x from 0 to 1, and y is also from 0 to 1. G is also from 0 to 1 because the x, y, g are the same. Okay, so A vector can be written in this way, and the DL component have the 3 component, but then you can do the dot product. Then you may obtain this result. Then it is simple to do. Okay. It's time to wrap it up.